Alright everybody, today's going to be our first chemistry lesson like I promised. So, I want to make it clear first before I start that this is a very rudimentary explanation of chemistry, and I'm starting at the very basics. I'm not going to go into the more complex chemistry equations and all that kind of stuff until we lay a foundation, starting with the periodic table and the atomic structure. So these lessons that I'm giving are starting with the assumption that the people watching have absolutely no knowledge of chemistry whatsoever in any way, shape, or form. Okay, with that said, I'm not a chemistry expert. I don't have my bachelor's or my graduate's degree in chemistry, so if I do make a mistake and you're more knowledgeable on chemistry than I am, please correct me without being an asshole. So without further ado, let's get started here. This is the periodic table, and any chemist will know that this is your best friend. You need to know this in and out. Not every element per se, but how to find certain things about that element. You need to memorize that. The periodic table is made up completely of elements, and an element is something that can't be broken down, a substance that can't be broken down further. Okay? Elements and everything you see are made up of atoms. Okay? So we're going to go here, and we're going to observe the structure of an atom here. All atoms that make up everything you see. Atoms make up everything in existence. So all atoms are comprised of three subatomic particles. You have your protons, you have your neutrons, and you have your electrons. Okay. Protons have a positive charge, and while electrons have a negative charge. Thus, they attract each other. The protons pull on the electrons, and vice versa, because they have opposite charges. It's kind of like two magnets. When you put the opposite poles together, they attract each other. Okay. Now, the third subatomic particle is the neutron. All right. The neutron has no charge. It actually has a neutral charge, hence the name neutron. All right. And the neutrons and the protons reside in the area of the atom called the nucleus, which is this area here with the yellow and orange protons and neutrons, and the electrons reside outside of the nucleus, and they kind of orbit around in different energy levels, which we'll talk about much later. But so this is the basic structure of an atom. Keep in mind that generally whenever you have an atom, you will always have generally an equal amount of electrons per protons. The only things that change are the numbers of neutrons, and when the number of neutrons are different in atoms of the same elements, they are called isotopes. But we'll cover more of that later. Alright? So let's start here on the periodic table. Once again, the periodic table is made entirely of elements. Elements make up compounds. Alright? H2O is a compound. If you'll forgive me here, I completely forgot to look up an example of a compound, so I'm going to do that right now. Okay. We're staring right now at a compound which is made up of elements. This is one of the more famous compounds, as we all know. This is water, a water molecule, which is a compound of hydrogen and oxygen, which has two hydrogens bonded to an oxygen. So, I guess the first thing that you have to understand is that the periodic table is made up entirely of elements, and elements bond together in order to form compounds. So back to our periodic table. There's a couple things that you have to understand and know about the periodic table. The periodic table gives you information on the element, starting with the symbol, which is in the form of a letter or letters for that element. C will always be carbon. Ge will always be germanium. O will always be oxygen. Okay, so there's the symbol that for each individual element, and that's how you find them on the periodic table. So if I told you to look up I don't know, hydrogen, you would go find H here, and you'd have to know that the symbol for hydrogen is H. It also tells two things called the atomic number and the atomic weight. If we go to carbon here, you'll notice, at least on this periodic table, the atomic number you'll always find in the upper left hand corner. For carbon, the atomic number is going to be number 6. Each element's atomic number is unique to that element. Thus, if I told you find me which element is number 7, and then tell me which element that is on the periodic table, then you would go to find number 7 on the periodic table, and you would know it's nitrogen. No other element can have an atomic number of 7. What the atomic number actually is a number that tells you how many protons that an atom of that element has. In this case, nitrogen has an atomic number of 7. Therefore, it must have 7 protons. Now, generally, like I said before, if you have 7 protons, you're going to have 7 electrons. There's generally always an equal amount of protons. An equal amount of electrons for protons. So if we go back here, this is a nitrogen atom, and like I just showed you, the atomic number for nitrogen is 7. So that means there's 7 protons. If there's 7 protons, then we should be able to count 7 electrons on this atom. 1, 2, 3, 4, 5, 6, 7. So that's how you would determine when given the periodic table and somebody asks you how many protons or electrons are in a certain element. That's how you determine it, by the atomic number. So the only thing that the periodic table doesn't tell you is the amount of neutrons in an atom of an element. And the reason because of that is because we have things called isotopes. Now every element has an equal number of every element on the periodic table, you can determine the protons and the electrons, but what happens is the neutrons vary. For example, you have things like different isotopes of hydrogen, which means that they're all hydrogen. They're kind of like variations of each other. They're all elements of hydrogen, but they have more or less neutrons. Okay, so we can go here, and here's our isotopes of hydrogen. There's 3